Today let us solve this particular problem. We are trying to find out the centroid for this composite figure. So here I can break this given figure into multiple pieces, like say for example let us consider the rectangle. So what are the dimensions of the rectangle? One side is 1000, that is this side. The other side is going to be 800 plus 400, that is 1200. So with this we are going to subtract a triangle. This is the triangle that is being subtracted because this is the cutout area. Only the shaded area, whatever is given, is the one for which we are supposed to calculate the centroid. So what is the dimensions of this given triangle? The base is 400 and the height is going to be 1000, and then again I'm going to subtract a semicircle. What is the base of the semicircle? Here it has been given as 800. So let us call this rectangle to be 1, triangle to be 2, and the semicircle to be 3. So we have totally 3 different components. Let us first write down the table for this. So here the first column is going to be components, and under that we have 3 different varieties. So for all the 3 we are going to have, followed by area. It is in mm². Then the next column is going to be xi. This is going to be in mm. The next column is going to be yi. This is also going to be in mm. Next column is a into xi, which is going to be in mm³. The last column is going to be a into yi, which is going to be in mm³. Now given that we have written the layout for our table, let us write down the components 1, 2, 3. 1, 2, 3. The question what they have asked us is to find out the centroid of the shaded area. So obviously the centroid is going to be about its centroidal axis that we are trying to calculate. So let us just write that the centroidal axis is going to be somewhere like this. Now coming to the rectangle, first we need to write down the area. What is the area of the rectangle? Length into breadth. So it is 1000 into 1200. 1000 into 1200. The second one is going to be the triangle. So what is the area of a triangle? Half into base into height. So it is half into 400 into 1000. It is 1000 over here. So it is half into base into height. Coming to the last one, so here what we need to do is, here we need to understand that this particular triangle is being subtracted. Can you see that we have written minus over here? Hence the area has to be subtracted. It's going to be a negative. Whenever we are going to be faced with cutouts, they are always going to carry a negative area. Please do not forget about that. It has to be negative. Now we are going to write the area of the semicircle. So area of the semicircle is pi r square by 2. It is going to be negative because it is a cutout. So minus pi into radius. Radius over here they have not mentioned. They have given the diameter as 800. So the radius is obviously going to be 400. So pi r square divided by 2. Now coming to xi we are going to start off writing from this particular point, be it your xi or yi, it is going to be always from the origin that we are going to calculate. The first one is your rectangle. For the rectangle, along the x-axis the centroid is going to lie at a distance of b by 2. So if this is your rectangle, say I'm going to calculate the centroid from here. Okay, because I have the point over here, so it is the centroid. So this is your b by 2, which is the centroid. So here the breadth of your rectangle is 1200, so it is 1200 divided by 2. Similarly, along y axis, if I am going to calculate the centroid, it is going to be d by 2, depth by 2. So that is going to be 1000 divided by 2. Coming to the triangle is over here. So if you just consider this particular triangle by itself, I can tell that the centroid lies somewhere over here. So this distance is going to be 2 by 3 times the breadth. Okay, the mass is more over here, hence the distance over here has to be closer. So this is going to be 1 by 3 of b. So from here obviously it is going to be 2 by 3 of breadth. But what we are trying to do is calculate the distance from here till here. So this is the point from where we are going to calculate. So this is the distance that is being found out over here. From this particular point to here, it's going to be first 800 plus this distance is 2 by 3 of b, so it is 2 by 3 into 400. Now coming to yi, along y axis, again the area is more over here, hence this distance is going to be 1 by 3 of h. So directly I can write it, because from the centroid, this distance or this distance, whatever you are going to calculate is going to remain the same if you are trying to do it about that particular point to that same line. So it is 1 by 3 into height is 1000, so 1 by 3 of h. Coming to the semicircle now. So for this particular semicircle, when we were talking about the standard sections, so there we had discussed that if you're trying to calculate the centroid for the semicircle, say to this point, okay, so say for example you're trying to calculate from here, let me call this as y axis and let me call this as x axis. So this distance is nothing but radius, but this distance is going to be 4r by 3 pi. So now first what we are going to calculate is the x distance, xi. So the centroid of your semicircle is somewhere like this. So this distance is nothing but this distance is nothing but radius, so that is 800 divided by 2. And coming to this distance, that is the centroid of your semicircle along y axis, it is 4r divided by 3 pi. So 4 into radius is 400 divided by 3 pi. Alright, now let us fill in the columns for a into xi. So a into xi is going to be 1000 into 1200 into 1200 divided by 2. Let us write it in the power of something so that it becomes very easy for calculation. So this is 720 into 10 to the power 6. Now coming to a into yi, it is 1000 into 1200 into 1000 divided by 2. So try to write this in the power itself. So this is going to be 600 into 10 to the power of 6. Now coming to the second component, that is your triangle. Can you see that we have already written a minus sign? Make sure you're going to write the minus sign over here also, else the whole calculation is going to be wrong. So first let us find out what is the value of this xi. So it is 2 into 400 divided by 3 plus 800. So this is going to be 1066.67. So 1066.67 multiplied by half into 400 into 1000. So write this also in 10 to the power 6 itself. Maintain 1 so that it becomes easy for calculation. So this is minus 213.33 into 10 to the power 6. Next, coming to a into yi, it is half into 400 into 1000 divided by, and then again 1 by 3 into 1000. So it is half into 400 into 1000 into 1 by 3 into 1000. So again you need to make sure that you are going to put a minus sign over there also. So write it in 10 to the power 6. So this is minus 66.67 into 10 to the power of 6. Now coming to the last one, that is the semicircle. Now under this particular value of semicircle, first let us write xi and yi. So yi is 169.76. A into xi, so it is pi into 400 square divided by 2 into 400. Write it in the power of 6, so it is minus 100.53 into 10 to the power 6. Then over here again pi into 400 square divided by 2 into 169.76. So write this also in 10 to the power 6. It is minus 42.66 into 10 to the power 6. Now let us write summation. First let us write summation of area. Let us fill this for easier calculation. So this is going to be these are all minus. Make sure you're going to write that minus sign. So summation is going to give you the answer. Make sure that you're going to include the minus sign when you're doing the summation also. So the area is 748,672.59. Now summation of A into xi, given that we have written it in common part, so it is very easy now when you're trying to do the summation. So this is 406.14 into 10 to the power 6. Now A into yi. So this is 490.67 into 10 to the power 6. Now let us write x bar and y bar. X bar is summation A into x divided by summation A. Y bar is summation of A into y divided by summation A. This is 406.14 into 10 to the power 6 divided by 748,672.59. and then 490.67 into 10 to the power 6 whole divided by 748,672.59. Let us do this particular calculation. So here x bar is 542.48 mm. Do not forget to write the units. The next one is 655.38 mm. So now we have found out the final value of x bar as well as y bar.